As you gaze into the vast, endless expanse of the night sky, watching the stars shimmer in their ancient dance, a timeless question inevitably surfaces: are we truly alone in the universe? This profound mystery has captivated the minds of philosophers, scientists, and dreamers for centuries. Today, with a new era of space exploration underway, we may be closer than ever to an answer. This monumental step forward comes through the development and deployment of the James Webb Space Telescope JWST, designed to observe deeper into the cosmos with greater clarity than any instrument before it. JWST functions like a powerful magnifying lens. It collects light that has traveled hundreds, even thousands, of years across the universe. One of its recent targets was a distant and enigmatic world known as K2-18B exoplanet located in the constellation Leo, roughly 120 light-years from Earth. Initially, K2-18b might appear to be just another remote celestial body, but closer examination has revealed something remarkable. K2-18b belongs to a category of exoplanets called sub-Neptunes, worlds larger than Earth but smaller than Neptune. These planets do not have direct counterparts in our solar system, which makes them particularly intriguing and somewhat challenging to understand. Traditional comparisons with Earth, Mars, Jupiter, or Saturn fall short. Sub-Neptunes occupy a middle ground, not quite gas giants, yet not entirely rocky like Earth either. Their uniqueness presents both a puzzle and an opportunity. Initial studies of K2-18b generated significant excitement among astronomers due to the possibility of life-supporting conditions. The planet orbits a red dwarf star named K2-18 at a distance of just 0.18 astronomical unit, much closer than Mercury's 0.39 astronomical units orbit around our own sun. Despite this proximity, K2-18b is not scorched or inhospitable. This is because red dwarf stars, while known for emitting bursts of radiation, are much cooler and dimmer than the sun. As a result, K2-18b resides within the so-called habitable zone, where conditions may allow liquid water to exist under the right atmospheric circumstances. JWST advanced instruments detected water vapor in the atmosphere of K2-18b, a finding that thrilled the scientific community. Water is one of the essential ingredients for life, but it is not sufficient on its own. Life as we understand it also requires a combination of specific environmental and chemical factors. Using spectroscopic analysis, which breaks light into its component wavelengths to identify various molecules, researchers found evidence of methane and carbon dioxide in K2-18b's atmosphere. These gases are commonly found in planetary atmospheres, including Earth's, and are not inherently signs of life. However, what truly sparked global interest was the tentative detection of dimethyl sulfide DMS, a molecule rarely observed outside of biological processes. On Earth, DMS is produced almost exclusively by living organisms, particularly microscopic marine life such as phytoplankton. It plays a role in forming clouds and serves as a potential chemical signature of biological activity. If the presence of DMS on K2-18b is confirmed, it would represent the most compelling biosignature ever discovered beyond our solar system. Although there's no evidence yet of forests, animals, or intelligent life on this planet, the possibility of microbial life in such an environment has captured scientific attention. The detection of DMS, still under verification, positions K2-18b as one of the most promising candidates for hosting extraterrestrial life discovered to date. In continuing our exploration, we encounter an emerging concept that challenges previous notions of planetary classification: the Hycean world. To understand K2-18b's full significance, it's important to consider this new model. In 2021, astrophysicist Nikumat Husudin proposed the idea of a unique type of exoplanet rich in water and cloaked in a thick hydrogen-dominated atmosphere. He coined the term Hycean planet, a blend of hydrogen and ocean, These theoretical worlds could be up to 10 times Earth's mass and twice its radius, yet they differ fundamentally from gas giants like Jupiter. High-seen planets are thought to possess vast oceans beneath dense layers of hydrogen gas. This composition allows them to retain enough heat for liquid water to exist, even at orbital distances where a planet like Earth would be frozen. In some cases, the ocean might constitute up to 90% of the planet's total mass. What makes these worlds especially exciting is their potential to support life in extreme conditions. K2-18b is now considered a strong candidate for being a High-seen planet. One of the major obstacles in the search for extraterrestrial life has always been finding planets that are both detectable and potentially habitable. High-seen planets offer a solution to both challenges. Due to their larger size, they are easier to spot with current telescopes, and their expanded habitable zones suggest they could sustain life at greater ranges of distance from their stars. Even at high temperatures potentially around 200 degrees Celsius, 390 degrees Fahrenheit, microbial life might survive in these deep oceans, particularly if the planet's atmosphere provides sufficient pressure and protection. Such life forms would likely resemble extremophiles on Earth, such as those thriving near hydrothermal vent or in acidic lakes. JWST's investigation of K2-18b employed a method known as transit spectroscopy. This technique involves observing the planet as it passes in front of its star from our vantage point. During this transit, starlight filters through the planet's atmosphere, allowing scientists to analyze which wavelengths are absorbed. This information reveals the chemical composition of the atmosphere. From just 5 hours of observation split across two transits, JWST detected the presence of water vapor, carbon dioxide, methane, and potentially DMS, while each molecule tells part of the story. Together they suggest a planetary environment capable of supporting life. Despite the promising data, scientists are cautious. Further studies are needed to confirm the presence of DMS and to better understand the atmospheric structure and climate of K2-18b. Future missions may provide more precise measurements, but the current findings already represent a major shift in our understanding. They suggest that habitable conditions might exist on planets vastly different from Earth, broadening the scope of our search for life in the universe. If high-seen worlds like K2-18b are common and early evidence suggests they may be, then the likelihood of life beyond Earth could be significantly higher than previously believed. This discovery marks a turning point, reminding us not only of the vastness of the cosmos, but also of its rich potential for surprises. The story of K2-18b is still unfolding, and with it, our understanding of where and how life might emerge across the universe.